another question on graph. We are given a graph of the first derivative, so this right here represents f prime of x. However, we are trying to answer questions with regarding to the original function f. So you know that this question is going to be tricky, but it's okay, we can handle it. First one, f is increasing on what interval? First of all, we had to associate how can we tell the original function is being increasing from the derivative. We know that if the first derivative is positive, that will tell us the original function will be increasing. If we are given a graph, what we need to do is, remember, anything above the x-axis is positive value, and anything below it, they have negative values. So in another word, for this question, I can change that to ask you, where is the graph above x-axis? So, as you can see, this part from 2 to 4, this part is going to be above the x-axis. So we know that from here to here, and let me write this down. This is going to be one of the interval between 2 to 4. The graph is above the x-axis, namely the first derivative will be positive. Where else? As we can see, anything after 6, from 6 to 9, it's also above the x-axis. So we'll put union 6 to 9. And that's it for the first one. Okay, for the second one, we are looking for where f has a local maximum. Let's do that first. How can we determine the local max by looking at the derivative? Remember, for the local maximum, what we need is f prime changes from positive to negative. In another word, above the x-axis to below the x-axis. So as you can see, okay, it's still below, it's above, but here, this point here, it changes from above to below at x is equal to 4, right? Above to below. So we have a relative or a local maximum at x is equal to 4. This is one of them. And in fact, I think that's the only one because there's nowhere else, okay? For the local minimum, we have to look for the place where f prime changes from negative to positive. For the local minimum, we have to look at the place where the graph changes from below the x-axis to above. Namely right here, right? It's below and it's above. So we have 2. That's one of the points, right? And we also have this point at 6 because once again, it's from below to above, from negative to positive. So we have 2 and I'll say x equals to 6. Well, 2 answers for that. Okay, and now part C, original function f is concave up on what interval? We are given the first derivative. To get concave up, we need to look at the second derivative. Well, so what can we do? For the second derivative, let me just write this down. For the second derivative, this means we can look at the slope of the first derivative. Okay? We can look at the slope of the first derivative to get the second derivative. Concave up means I want the second derivative to be positive. So in another word, I want to look for the slope of the first derivative to be positive. Meaning, I want to look at the graph and determine where is it going upwards. The first derivative graph has to be going up. The first derivative graph has to be going up. I can do it again. The first derivative graph has to be going up. Okay, so let's see. From 1 to 3, this right here is going up, right? So 1 to 3. Where else? From 5 to 7. So union from 5 to 7. Anything else? Yes. From 8, this is meant to be 8. From 8 to 9, it's also going up. So the third one from 8 to 9. And that's concave up. And now for concave down, you just look at the opposite. I want the graph to be going downwards. So in another word, from 0 to 1, that's the first one. And going down from 3 to 5. So I'll put union 3 to 5. And 7 to 8, and the little piece right there. So union 7 to 8. And that's it. Lastly, I would like to know where f has an inflection point. For the inflection point for the original, that means the second derivative changes signs. But then the second derivative means the slope of the first derivative. And in this case, it will be the place where the graph changes from going up to going down. So it will be right here, right? Going down to going up. That means the second derivative will be changing signs. So it will be here 1, 3, 5, 7, and 8. Okay, which is pretty much the relative minimum or maximum for the first derivative. 1, 3, 5, 7, 8. So let me write this down. 1, 3, 5, 7, 8. 1, 3, 5, 7, 8. That's it.